So this is grade 7, chapter 5.5, conduct probability experiments. So the theoretical probability is what's expected probability of an event occurring. So when you flip a coin, you think that there's going to be 50-50 chance of it landing heads and tails. The experimental probability is what actually happens. So even though it's supposed to go heads or tails pretty evenly, you could get 15 heads in a row. It's pretty rare, but that's the probability. So example 1, comparing theoretical and experimental probability. A group of researchers wanted to determine the probability of having a girl or a boy in a 2-child family. So what is the theoretical probability of a family having 2 boys? So the first boy or first child has a 50-50 chance of being a girl or a boy. The second child has a 50-50 chance of becoming a girl or a boy, which means that let's make this into a tree. So the first one is going to be a girl, the second one is going to be a boy. On the second chance, they have a 50-50 chance of getting a girl, 50-50 chance of getting a boy. If there was a boy, the 50-50 chance of getting a girl and a 50-50 chance of getting a boy. So what we're looking for is this right here, boy, boy, out of all these possibilities. So 1 out of 4 is your possibility, so 25%. That's the theoretical probability. So the researchers studied 20 different families and displayed their data in a chart. What is the experimental probability of a family having 2 boys? So what we have to do is we know it's out of 20. So let's go through and check mark every time there's a girl and a boy. So boy, boy. Girl, 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 boy, girl, boy, girl, girl, boy, boy. Boy, 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 girl, boy, 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 girl, boy, boy, girl, boy, boy, girl, boy, 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 girl, boy, girl, boy, girl, boy, boy, girl, boy, boy, and a girl, boy. So out of 20, there's 1, 2, 3, 4, 5, 6, 7 out of 20. That's a 35, sorry, out of 20. That's 35% of the people that they studied had a boy-boy family. That doesn't mean that there's a 35% chance of having a boy-boy family or boy-boy pair once you have kids. That would leave that isn't the math. But out of the families that they've seen, they found that it was a 35% chance of the experimental versus the theoretical probability. So the example 2. Katie is on the school volleyball team. She has a 75% chance of successfully serving within the boundaries. Which means that out of all of her serves that year, 3 out of 4 of them landed inside, or 75 out of 100. She has had a success rate of 75%. Katie's very good. That's a very good serve for junior high volleyball. So what is the theoretical probability that she will make 2 successful serves in a row? So our 2 choices are in or out. So if the first one lands in or out, the second one lands in or out. That means the second one could be in or out. So she has right here 2 in a row. That's a 2 out of 4 possibilities. That's 1 in 4 equals 25%. And she has 75%. Now, this is a little different because, when you add skill into it, it's not 100% that this is completely random. So we're going to use the spinner to conduct an experiment for the above situation. What is the experimental probability of making 2 services in a row? So we're going to say green is in, red is out. So when we hit this, the first one was out. The second one was in. Did she make both attempts? No. The second one was in. And the second one was in. So yes, she made this. Theoretically, let's keep going. On the third trial, it was out. And it was in. Did she make both? No. First one was in. The second one was out. So did she make them? No, not at all. So out of our attempts, out of our spinners, out of the first 4, instead of going all the way to 8, what is the experimental probability? Is 25%, because we have 1 yes and 4 no. So our experiment matched up with the actual probability of making it in and out. Okay? So the last one, 2 coins are flipped. What is the theoretical probability of getting a heads and a tail? Heads or tails are the 2 options. So when we go heads and we go tails, the choices are again heads and tails, heads and tails. So we have getting a head and a tail. We have 1 here and we have 1 here. So our chances are actually 2 out of 4, so 50%. This is a fun experiment. So if you have a coin, or if you have a coin in your locker, go get it and conduct an experiment and calculate the experimental P of head and tail. So how many times you could do this? 5 times or 10 times, and see if every 50% you have head and a tail, or a tail and a head. Thanks for listening. If you have any questions, come see me. Your questions are up on social7.ca. Thanks.